Good morning. Myself I am Dr. S. Kalaiselvi, Assistant Professor of Maths. Today in class we will see about skewness and kurtosis. From this video we are going to learn about skewness and kurtosis. And skewness and kurtosis are statistical measures that describe the shape of a probability distribution. Then skewness indicates the asymmetry of the distribution, while kurtosis indicates the tailedness or peakedness. In this, the skewness is going to describe about the asymmetry of the distribution, and kurtosis will give the detailed explanation about the peakedness for the given curve. Here we are giving the skewness and kurtosis in the pictorial representation. First one is about skewness. When the skewness is positively skewed, then the normal curve will be right-tailed, and if the skewness is negative, then it will be the normal curve will be left-tailed distribution. Then about the kurtosis, we have to know about the normal curve. If the normal curve is in the center in this figure, then if the curve is get more peaked, then it will be positive, and also the curve will be negative, then it is flatter than the normal curve. Here we are going to know about the skewness. Already we know skewness means the symmetry of the distribution. Here also it means the lack of symmetry, that is the asymmetry of the distribution. In a figure, the symmetric curve is called if there exists a point in it through which if a perpendicular is drawn on the x-axis. That is, the figure will be divided into two congruent parts. First part is identical and the next part is superimposed on the other. In this, the superimposed means mirror image of the other one. In statistics, the distribution is called symmetric if mean, median and mode, three measures will be coincide to each other. If a distribution is symmetric, then these three measures will be coincide. Otherwise, we can say that the distribution is asymmetric. That is, mean, median and mode, three measures will not be coincide with each other. Now let us know about the positively skewed distribution. Already in the figure we show that the right-tailed distribution is called positively skewed and the left-tailed distribution is called negatively skewed. If the right tail is longer, we get positively skewed distribution. In this positively skewed distribution, the three measures mean, median, mode get the relationship as mean is greater than median and median is greater than mode. Vice versa, if the left tail is longer, then we get negatively skewed distribution. Here also we are getting the relationship between mean, median, mode as mean is less than median and median is less than mode. Next we will see about the measures of skewness. Measures of skewness is both in which we get absolute as well as relative. First let us know about the absolute measures of skewness. Here we denote the skewness as Sk, that is skewness. First measure of skewness is between mean and median, that is mean minus med. Then second measure of skewness we will get mean minus mode. Then third measure of absolute skewness we will get between the relations between the quartiles, that is Q3 minus Q2, then Q2 minus Q1. Difference between these two measures also we get the absolute measure of skewness. Then we know about the relative measure of skewness. Here we get the relative measure of skewness in terms of beta 1. Beta 1 is known as relative measure of skewness. It is measured between mu3 and mu2. Formula will be mu3 squared divided by mu2 cube. In the same way, the direction of skewness is also measured by, if we take the square root of this, we will get square root of beta 1, which is known as mu3 divided by mu2 power 3 by 2. These two measure of skewness are known as absolute measure of skewness and relative measure of skewness. Then this relative measure of skewness is also known as Kalaiselvi coefficient of skewness. This Kalaiselvi coefficient of skewness is most frequently used for measuring skewness. Then the formula for measuring the coefficient of skewness is known as mean minus mode divided by sigma. Here the value of this coefficient, that is the coefficient of skewness, will be 0 in a symmetrical distribution. Then what will be the positive skewness and negative skewness? It is, if the mean is greater than mode, coefficient of skewness would be positive. If the mean is less than mode, the coefficient of skewness will be negative. It is known as positive skewness and negative skewness. That is, mean is greater than mode, we will get positive skewness. If mean is less than mode, then we will get the coefficient of skewness as negative. If the value of Kalaiselvi coefficient of skewness is between plus or minus 1, then the skewness will be told as moderately skewed. It is known as moderately skewed distribution. Next, let us know about the skewness for the normal distribution. In normal distribution, the value of the skewness will be 0, then it will be called as symmetrical distribution. In this, we are having the skewness value will be very near to 0, that is 0.001 something. In negative skewness, we also indicate the skewed value will be left, and the positive values for the skewness indicate the data are skewed right. Already we know that right-tailed means it is known as positive skewness, left-tailed means it is known as negative skewness. In the same way, by skewed left, the left tail is long relative to the right tail. In same way, the skewed right means the right tail is long relative to the left tail. Then, if the given data are multimodal, then it will affect the sign of the skewness, because if it is right tail, then we can easily say that it is positively skewed. If it is left tail, it is also known as negatively skewed. But in multimodal skewness data, we are not able to assume that it will be positively skewed or negatively skewed. So, it will affect the sign of the skewness. In this slide, we are know about the skewness, in which situations the skewness does not exist. First one, if the value of the mean, median and mode are same in any distribution, then the skewness does not exist in the distribution. Already we say that mean, median, mode are coincide, then the symmetric will be lake. Therefore, the skewness does not exist in the given distribution. If the value of mean, median and mode has different values, that is the value of the mean not equal to median and not equal to mode, then it get the larger difference, then the skewness also larger. Therefore, we can say that the larger the difference in these values, larger the skewness. In second situation, if the sum of the frequencies are equal on the both sides of mode, then the skewness also does not exist. This one is second situation. Then in third situation, if the distance of first quartile and third quartile, that is Q1 and Q2, between Q1 and Q2 the distance are same from the median, then a skewness does not exist. In the same way, in deciles also, that is D1 first slide and D9 ninth decile also, we get the same, the distance are same from the median, then skewness does not exist. In the same way, in percentiles also, that is in first percentile P1 and 99th percentile, that is P99, are at equal distance from the median. Here also we are not able to get the skewness. Then we can say that there is no asymmetry. In the fourth situation, if the sums of the positive and negative deviations, that is mean deviation, median deviation, are from the mode are equal, then there also symmetry does not exist. So we can say that there is no asymmetry. In fifth one, if a graph of a data become a normal curve, and when it is folded at middle part and the other part will be overlap fully on the other, that is one part is coincide with the other part, the other one is there is no distance between these two values, hence there is also skewness does not exist. So we can say that there is no asymmetry. In next slide we know about the kurtosis. Here kurtosis means the curve's peakness, that is the degree of the kurtosis of a distribution is measured relative to that of normal curve. If the curve with greater peakedness than the normal curve, it is named as leptokurtic. Next curve is which is more flat than the normal curve. In this situation, the curve is named as platykurtic. Then last one is same as the normal curve. It is known as mesokurtic. Three names are exist for kurtosis, that is peakedness of the curve. If it is greater than normal, then it is leptokurtic. If it is flatter than normal, it is known as platykurtic. If it is same as normal curve, it is known as mesokurtic. In this slide, we are get the details about the applications where we are going to apply these skewness and kurtosis in our real world. Here, skewness provides us the given data is symmetric or asymmetric. Here we are going to get insights how the symmetric data is. In finance, the financial analyst use skewness to assess the asymmetry of returns on assets. When they invest their assets, they will expect more return from their investments. So, if the investments with high skewness might be riskier, but they also offer chances for the high returns, even though when we apply the high investment, but we are able to get more profit from this skewness analysis. Then what about accurate data interpretation? For this also we are able to use the measures of skewness. It will give the shape of the data. For example, a positively skewed income distribution gives the most people earn less than the average income. In the same way, in finance, the skewness of investment returns helps in assessing risk also. Next one, how can we apply the kurtosis? Kurtosis helps to identify in finance the presence of outliers of the data. What are all the outliers in the data? We are able to know from the kurtosis. Then this kurtosis also measure the tailedness of the distribution. Already we say that if the normal curve is greater than the curve, then the greater curve is known as leptokurtic, and normal curve is flatter than the given curve is known as platykurtic. Therefore, skewness also measures the asymmetry of a distribution. Tailedness measures the kurtosis of a distribution. Meanwhile, skewness indicates the direction and degree to which the data deviates from a symmetrical bell curve. Here, the symmetrical bell curve is known as the normal curve. A distribution with zero skewness is perfectly symmetrical. In symmetrical, the good measure will be possess three criteria. That is, first one is unit free number. It gives the shape of the different distribution so far as symmetry is concerned. It can be compared even if the unit of the underlying variables are different. If the distribution is symmetric, the value of the measure will be 0. Similarly, the measure should be positive. It will be, skewness will be positive. If it get negative values, the skewness will be negative. It is negatively skewed data. As we move from the extreme larger skewness to the extreme positive skewness, the value of the measure should be varying accordingly. Measures of skewness can be both absolute as well as relative. In a symmetrical distribution, about mean, median and mode are identical. More than the mean, it moves away from the mode. Hence, the larger the symmetry or skewness. An absolute measure of skewness cannot be used for the purpose of comparison because of the same amount of skewness. It has the different meanings in distribution with small variation and in distribution with large variation. Here in this video, we have discussed about what is skewness and the significance of skewness, and the type of skewness exists in different kinds of distributions and different kinds of measures of skewness also. And we are now able to calculate the coefficient of skewness, what is kurtosis and the significance of kurtosis. Then we are know about the different measures of skewness. How can we calculate the coefficient of skewness? From next video, we are able to see the curve fitting for the given curves. Thank you.